Discuss some problems based on electric field and electric dipole. Say we are having a pair of two charges plus 2e and minus 2e. They form a dipole and the length of dipole is 2 angstrom. Means the value of 2L is 2 angstrom and this dipole is placed in an external uniform electric field of 4 into 10 power 5 volt per meter. We have to calculate the dipole moment. Second, potential energy of the dipole in equilibrium position. And second, work done in rotating the dipole through an angle of 180 degree from the position of stable equilibrium. Now you know dipole moment is Q into 2L. So in this case, the value of 2L is 2 angstrom. So we take 2E into 2 into 10 power minus 10. Substitute the values. So we are having 4E into 10 power minus 10. On substituting the values and solving, we get 6.4 into 10 power minus 29 coulomb meter. Second part, potential energy in equilibrium position, that is minus P dot E or minus PE, because in this case theta is 0, and substitute the value of P and E, so we get 2.56 into 10 power minus 23 joule with negative sign. Last is saying work done. The work done is P cos theta 1 minus cos theta 2. Question is saying in rotating it from stable equilibrium to unstable, means theta 1 is 0, theta 2 is 180, substitute the value, cos 0 is 1 and cos 180 is minus 1, so we get value 2 times P into E. So we can say 2 times of potential energy with plus sign. So we get 5.12 into 10 power minus 23 joule. Next question is, this question was there in 3 marks in the board exam. Question was saying ki write the expression for torque and then identify 2 pair of vectors which are mutually perpendicular and then draw the orientation of the dipole in the external electric field when the torque acting is having maximum value and half of maximum value. So you know torque formula is tau is P in E sin theta, or we can say P cross E. Now tau is perpendicular to the both P and E, so we can say 2 pair of vectors are tau and P and tau and E. Now maximum torque is PE. When we have to show that when torque is maximum, then angle between P and E will be 90 degree. So in this case, for stable one, means the diagram will be like this is your electric field, then this is minus Q, this is plus Q. So this is the direction of dipole moment and this angle is 90 and this is E. So this is for position of maximum torque. And for half of maximum, you know value will be PE upon 2. So by formula PE sin theta, value of theta should be 30 degree because sin 30 is half. So we will show the orientation. Minus Q and plus Q is the dipole and the dipole moment makes an angle of 30 degree with the direction of electric field and this is the direction of dipole moment. So in this case, if you see, they haven't asked for the derivation, but they have asked for the application of the formula and the logics which we have applied till date. Now next question we are taking, this is the, like for example they have asked, like we have taken 3 points on the x-axis and 3 points on the y-axis at equal distance from point O. Question was saying at point O we are having some electric charge distribution. What is there means single point charge or the dipole or anything else that we don't know. But points are at equal distance. Means here also the distance between points is R, on y-axis it is also R, and the values of electric field at these points are given in the table. The question was saying on the basis of these values, you have to identify the type of charge distribution kept at point O and you have to justify your answer. In this case, you know one thing, when you have done the formula, if you see the values, for first point distances are, second point 2R, third point 3R. And if you see the values, E by 8, E by 27, so basically we can say the value is varying with the inverse power 3 of distance, or you can say directly proportional to 1 upon R cube. Secondly, when you see the value on x-axis at a distance R is E and y-axis the value at the same point, means same distance is E by 2. Same, this is there for all the points. So you know one thing, if for electric dipole at axial point, electric field is 1 upon 4 pi epsilon naught into 2p upon r cube. On equatorial point, it is 1 upon 4 pi epsilon naught into p upon r cube. So value of y-axis is half of value on x-axis at the same distance. So here we have to justify by saying that since E is directly proportional to 1 upon R cube and value on y-axis means Ey is Ex upon 2. So distribution is a short electric dipole. Next question we are taking. Say the question was there for 3 marks in the boards. In a certain region of space we are having an electric dipole AB. It is placed in direction opposite, means in such a way that dipole moment is opposite to electric field. But in this case, electric field is not constant. It is increasing at the rate of 10 power 5 Newton per Coulomb in the positive z direction. So question was saying, in this case, calculate the force acting and the torque acting on the dipole. Now, since electric field is not constant and question is saying your dipole moment is opposite, so we take minus q up and plus q down because dipole moment direction is from minus to plus. So in that case, if we take the value of electric field at point B as E, then EA will be E plus 2L into 10 power 5 because distance between these two charges is 2L and electric field is increasing at the rate of 10 power 5 Newton per Coulomb per meter. And force is Q into E. The net force will be minus Q, E plus 2L into 10 power 5 because this is the value of electric field at point A. And then plus QE for the charge at point B. So we get the value as minus Q into 2L into 10 power 5. Q into 2L is dipole moment. So we substitute the value of dipole moment in the question, which is given 10 power minus 3. So 10 power minus 7. So on solving, we get the value of final answer. Minus 10 power minus 2 Newton means direction of force is from A to B, means opposite to electric field. Now since the line of action of these two forces is same, means along the line AB only, so no net torque will act on the dipole in this case.